All right, what's up, everybody? Welcome to another episode of Model Monday Live, the Gamified CAD web stream, live stream, where you get to compete against the chat to see who can turn a 2D drawing into a 3D model the fastest. And of course, all of you out there are welcome to compete using any 3D CAD system. That's what really makes this a lot of fun. We get to see who is the fastest in the chat, regardless of what CAD system they are using. Now, today is a very special episode because last week we messed up the number. I had a little problem with how I was entering the number 36.6 versus 33.6. So because of that, we ended up not having the extra point last week, the second point last week. So this week we are going to have 3 points up for grabs, and it's going to be a special episode. So what I want you to know here today is that we're going to do 3 CAD speed modeling challenges instead of 2. We're going to do some live updates. We're mainly going to focus on the LiveSolve though and the CAD updates. And I'm going to solve these right along with you using 3 different CAD systems: FreeCAD, Onshape, and SolidWorks. So I'm going to be competing against you guys. All right, we're going to see who is the fastest in the chat and who can beat Toby at 3D CAD modeling. So good luck to all of you. And if anybody's able to beat me, congratulations. You get a bonus. You get a bonus. Today, but we're giving out bonuses like crazy today. So I want you guys to understand, if you're here for the first time, this is what you're going to need. You're going to need the materials, and the materials need to be correct. And you're going to need a free account on TooTallToby.com. We're going to post all 3 of the challenges today on TooTallToby.com. Now, I am going to show the challenges here on the live stream. So if you don't have an account, that's okay. You can still play along with, but you're not going to be able to earn the points. If you're looking to earn those points on the Model Monday Live leaderboard, you got to have a free account at TooTallToby.com. So get over there, sign up. There's still time to sign up. And your material densities need to be these material densities. Now, if you're in the TooTallToby Discord, or if you go down into the Discord, if you go into the link down below into the Discord, there's a channel in the Discord called Materials Tools, where we've got the library posted for Onshape users, or for Fusion users, or for SolidWorks users, or for Inventor users, or for FreeCAD users. So if you are using one of these CAD systems and you want to compete today, you have to have these materials ready to go. Otherwise, you're not going to be able to calculate the mass correctly. You can either input that manually as just like a custom material in your CAD system, or you can go to the Discord and you can grab those materials and update your libraries. I mean, I guess you could create your own library if you wanted to on the fly pretty quickly here. We are going to do some intros. We're going to say hello to everybody, so you do have a few minutes still. But these are the 2 things you're going to need to do. Sign up for a free account at TooTallToby.com, because we're going to post the challenges right there on the practice page at TooTallToby.com. And make sure that your materials are correct. You need to have the correct materials in order to do this. Don't see a link for the Discord. It should be down below in the chat. If it's not down below in the chat, in the description. If it's not down there in the description, maybe Vicky can grab it and drop it into the chat here. But it should be down there in the description of the video. I usually put it in the description. If I don't, Vicky, maybe you can grab it from the description of like the tournament. I'm sure I put it in there. I usually put it in the Model Monday Live description too. So guys, you need to have your materials correct. You need to have a free account at TooTallToby.com. And with that, we're going to just say hello to some people. We're going to do just a little bit of housekeeping here, kind of welcome everybody to the live stream. But I wanted to just make that announcement before we got started. Make sure you've got your materials set up correctly. Make sure you've got your free account at TooTallToby.com, and then we'll get there. Nothing in the description. All right, thank you, Matab. I will stop saying that. Tom Dunn says, keep hitting the like button, people. Yeah, that's what's up. So guys, I saw a piece of exciting news here in the chat as I was going through getting ready for today, and I saw that Het Patel, brand new to the world of 3D CAD speed modeling, had his first matchup this last week. Unfortunately, got knocked out of the tournament, but it's all about getting that experience. And we can see here that Het Patel in the chat says, from battling in my first World CAD Championship last Friday to winning my University CAD Championship today. Yo, that is awesome, man. GG to Het Patel. Congratulations and good game and well done, my friend. Says, looking forward to more. Thanks for all the support and guidance. That is awesome, man. Congratulations. And Pico Boo is in the chat, says hello, hello. And Ricardo Jean is here, says hello, hello. Welcome, welcome, everybody. Guntis is here, says hello. Anand is here. Hello, my friend. Welcome. And Gray is here, says peace. What's up, my man? Welcome, welcome. And Dan Does says, is there a Discord for this? I just started learning Fusion 360 a couple of days ago. Yep, and I answered that down below. And Anthony is here, says, hey, Toby. And let's see here. Jim U. Carbaros is here. What's up, man? Welcome. Thanks for joining us today in the live stream. Great to see you. And Ray R is here. What's up? What's up? AMO Alex is here. Sorry about that, Mr. Alex. Welcome. Welcome. Great to see you. And Ray R is here. Hello, Ray. How are you? And Dan Does says, found you by your Reddit post. Nice. Thank you. Glad that the Reddit posts are working. And Gummy is here. Says, hello, everyone. Hello, my friend. Thanks for joining us. Tom Dunn, long time no see. Good seeing you in here. Usually we see Tom in the comments after the live stream is posted. But great to see you here in the live stream, my man. And Rambro's Workshop is here. Says, hello. Hello, hello. And Paragene is here. Good evening. Good evening, my friend. Matab is here. Says, hello. Ricardo Jean says, hello. Arend here says, hi, all. Hello, hello. Sebastian is here. What's up, my man? And let's see here. Matab is here. Lawrence is here. Says, sup. He's here with Onshape. Yo, that's what's up for sure. Mr. Intrusionist is here. Rock Crawler in the house. Let's go. Says, hello, everyone. And let's see here. Don't forget to hit the like button. Good game. Guntus, good. PCRDuino is here. Welcome. Very glad to see you here in the chat today, my friend. You'll see why in just a couple of minutes. And Aaron C is here, says hello, hello. And PWG is here, says hello. And Ali Ja is here, says hi. And Pico Boo is here, says, where's the material list in Discord? I don't see it anywhere. It's in the hashtag materials tools server. Hashtag materials tools. Hashtag materials dash tools, I think is what it's called. Let me see here. There it is. Hashtag materials dash tools. You might have to right click on the name of the server and say show all. Show all. Vicky says she put it in the community discussion section as well, the link to it. Thank you. All right, guys, here we go. Very special episode. Usually the flow is a little bit different. If you're here for the first time, you came at the right time. This is going to be an awesome episode. We're going to blast through these challenges. So here we go. Everybody who's here, welcome, welcome. And Mike Rango is here. Ragno is here. What's up? Welcome. Thanks for joining us. And guys, welcome to today's episode of Model Monday Live. Normally we do 2 challenges for the chat across the hour, and we usually are cruising at a pretty good speed. Today we're going to try and do 3 challenges for you, and I'm going to try and solve them right along with you. For the very first challenge, I'm going to try to solve using FreeCAD. So here we go. Here's what you're going to do. You're going to visit us at TooTallToby.com, and you're going to get yourself a free account, and then we will get you up and running. Anand is here using NX. Yo, let's go. I can't wait to see how you do, my friend. We always see NX users in the comments saying how fast it is. So now we're going to get a chance to see somebody using it, and I'm very excited for that. So, guys, real quick, I just want to say thank you so much to everyone in the community, all the subscribers, the joiners, the tutorial makers, Practice Models Premium users, student sharers, commentors, and the entire Discord crew. TooTallToby community would not be what it is without all of you. I thank you and apologize for the abbreviated list. Please take a moment, hit the like button, subscribe to the channel, share and reshare. This is a very special episode. We're kind of speed running this episode of Model Monday Live. So what I'm going to do right now is I'm going to show you guys a 2D print, or actually I'm going to have you go to the TooTallToby website. Now, if you don't have an account, I'll still show you the 2D print so you can still play along. But if you go to the TooTallToby website, you're going to see a brand new practice model posted in just a moment. You're going to try to calculate the mass and then enter that mass in the app, and you'll see how that app works in just a moment. Your materials have to be correct. If you haven't grabbed the correct materials yet, then please take a screen capture of what you're seeing here. Pico Boo, you might have to right click on the name of the server. I see Pico Boo made a comment in the chat, says I don't have the materials in the list. You may have to right click on the name of the server in Discord, and then you can say show all. Something like show all channels, basically, is what it is. Show all channels or display all channels. Something that Discord does. If you add a new channel, it doesn't automatically show up in people's lists. And guys, you need to make sure you have these correct materials in order to compete. And that's basically it. Use whatever CAD system you want. Make sure you enter the correct precision. We're going to use the leaderboard at TooTallToby.com to determine the winner. The winner will earn a coveted point here on the Model Monday Live leaderboard. And look at Rambro's Workshop closing the gap here between himself and Aaron C. We might have a new winner. Aaron C won the Model Monday Live leaderboard last year, and he might win it again this year. The F5 gang is ready to go. F5, yeah, the whole refresh on the webpage does kind of introduce a new dynamic. I'm not sure that I like it. I might go back to to this original. I love having the leaderboard on the website, though. Pros and cons, like always. We're engineers here, so we're always thinking about the pros and cons. Let's not take too much time, though, because we got to do 3 challenges today. So here we go, guys. Here's what we're going to do. We're going to have you guys go to the website, www.TooTallToby.com. We're going to have you guys sign up for a free account on the website, www.TooTallToby.com. Once you go to the website, www.TooTallToby.com, and sign up for a free account, you're going to see here that with a free account, you can access there's a limited library. There's about maybe like 10 or 15 challenges that you can access. But in just a moment, you're going to see the homepage, the library page, the play and learn practice models page here is going to update. And when it updates up at the top of the page, you're going to see that we've got a very special challenge sponsored by our friends over at CADOp.io. And CADOp.io is a modern cloud-force platform for CAD documentation. So here we go. It just went live. If we go here to practice models, we're going to see that at the top of the practice models list, we've got CADOp.io. And on underneath CADOp.io, we've got our brand new challenge, 250907. Whoever can get in there, click here to practice, model up this drawing or turn this drawing into a 3D model and answer correctly in the app will win the first point of the day. Now, we're going to do 3 challenges today, which means we're going to be adding 3 challenges here in this week's featured challenges. And this week's featured challenges are sponsored by CADOp.io. CADOp.io is a tool that can help you with CAD documentation and with reducing the overall time that it takes for engineers to manage and communicate through CAD documentation. You can cut that time down by up to 90%. And the way that you're able to do that is you're able to load up your assembly, maybe take a step file, load it into CADOp.io, and then you're able to create a bill of materials. You're able to examine the individual components, get the technical specs, do cost breakdowns, and it all happens almost instantly on a web browser. So check them out, CADOp.io. It's actually a member of our community who created this. So CADOp.io is a really cool solution. I love having members of the community developing their own tools to help the community. So check it out, CADOp.io. They're sponsoring this challenge. And let's get into our very first live solve here today. Here we can see what this first challenge looks like. You can see that this challenge is called Sponge Tray. So we see here that this is a tier 4 challenge and the material is ABS. So if you're out there, if you're just watching, if you don't have a TooTallToby account, that's okay. You can still play along with. You can still enter your answer in the chat, but we're going to accept the point based on our leaderboard on the website. So if you don't have a free account yet, that's okay. You can sign up for an account. And then you can compete in the second and third challenge that we're going to be doing today. Today's going to be a little bit of a speed run, a little bit of a rush here, because we're going to try and do 3 challenges in one single episode. So here we can see what that challenge looks like. If you haven't had a chance yet, maybe grab a screen capture of this. I'll make it full screen for you so you can grab a screen capture. And then I'm going to jump into the TooTallToby app, and I'm going to solve this in the app. I have a free account at TooTallToby.com, so I'm going to use that app at TooTallToby.com/practice, and I'm going to try to model this part up. But this is kind of a cool part. It is another 3D printable part. This is something that you would use in the kitchen. You could place your sponge on here, and the extra fluid, the extra water and soap will just run off and right down into the sink, and that way you can kind of, you don't have to have that extra sponge material on your actual countertop. You can have it run right into the sink. Kind of a cool 3D printable model. So here we go. Let's get into the TooTallToby app and let's see what we would do to model up this part. And Mr. Intrusionist says, I have one of these 3D printed. It works great. Yo, that is awesome. Congratulations. That's a great part to 3D print. So let's get into it here. We're going to go into the website, TooTallToby.com. With a totally free account here, you can say access full library, and then you can go down here to this featured challenge, thanks to our friends at CADOp.io. These challenges will be up there, and they change every week which challenges are the featured challenges, and they give you all the functionality that you would get with Premium, and that way you can kind of examine what's going on with Premium tools like try again, the ability to run the same model over and over again, things like that. So we're going to get in here. We're going to say click here to begin and go. And so the question here is, what is the mass of this part in XXX grams? We're going to try to solve that, and we're going to try to enter that mass right down here. Now, if you're a newer user to the world of CAD, you want to follow a basic game plan every time, which is where should the origin be located on this part? and what should my very first sketch look like. So usually what I do when I look at a model, if it's in 3D or if it's in the real world, what I'll do is I'll kind of break down the model into different areas. So I think that for this model, the first area is going to be kind of this main deck here. Maybe this little ledge that's sticking down and this ledge up the back, but really this main deck is where all the action is taking place. Then my second element is going to be maybe the sidewall here, which could be mirrored. And then my third element is going to be one of these fins, which could then be patterned. And then finally, I'm going to apply the fillets, apply the material, and then measure the mass. So first thing I do is I kind of come up with a game plan and break the model down into different features, and you'll get better and better at that as you get more experience. But then what you want to ask yourself is, where should the origin be located? And what I'm always looking for is, are there a bunch of dimensions that are coming together at one common datum or one common reference point? And you can see here that all the dimensions that I'm circling, they are all using the same kind of reference point, the same kind of datum. So I think that in the case of this model here, my origin is going to be down here in the lower left corner of this front view. And then once I've got that origin located, I can get in there and create my first sketch, which is going to be this main kind of deck area. I'll leave everything sharp. I'm not going to add the fillets till last, but that's going to be my first sketch. And then I'll extrude that sketch mid-plane so that my model will be centered. So the origin will also be here, kind of centered. Then for my second feature, I'm going to create one of these sidewalls. So this kind of sidewall shape here. I'll just kind of match up the original shape and then mirror that over to the other side, over to here. And then finally, for my third shape, I'll create this extra shape that's kind of tucked away in here, this little rib shape, and then I can create a pattern of that rib shape. Add the fillets, add the material, and I'm going to be good to go. So here we go, guys. If you haven't seen FreeCAD before, this might be your first chance. Now I know there are some real speedy users out there, so I'm just curious. I'm going to go back to the main page here. I'm going to click here on what's called First 42, and I'm going to refresh my page here. I'm just curious if anybody has solved this thing already. So look at this. There's already been 5 people who have solved this thing just since we started talking about it a few minutes ago, and well, I'll save the leaderboard here until the end of the video. We'll find out who earns the point today. So let's get into it here. Click here to begin and go. And now the clock is running. I'm going to say open in new window, and that way I can move this window here over to my second screen. Whoops, it closed out of some of my other apps there. And then we are going to, hold on one second. Let me just get my bearing back here. We're gonna bring up let me bring up the app again. Sorry about that. In Windows, if you shake the window, it will minimize all the windows that you have open. So I'm going to bring up my keyboard cam here, and then I'm going to go into FreeCAD. If you guys have never seen FreeCAD before, this might be your first time seeing this and kind of seeing what this workflow might look like to model up a part like this. But if you are a FreeCAD user, I hope that you'll be able to use this as kind of a tutorial, going to help you think through a model and maybe pick up some good tips and tricks that you could use in FreeCAD. Now, keep in mind, I am kind of a FreeCAD noob here, so I'm going to start by beginning a new parametric part, and then I'm going to expand this menu here, origin, my axes, and my planes. And a lot of times I like to just turn on my plane so I can kind of see what's going on screen there. And then I'll pick one of these planes. I'll pick this one here, this XZ plane, and then I'm going to use a shortcut key, Shift S. Now, I've customized my shortcut keys in FreeCAD, and I've made a video all about how I kind of got to the point that I'm at now and settled on the point that I'm at now as far as my customized keyboard shortcuts go. So I'll link to that video down below. But here you can see that following my game plan, I'm going to start out here with the polyline command in FreeCAD, the polyline command, and then I'm going to single click here on the origin, move over, and I'm going to sketch the geometry kind of for that deck. So this is going to come over to about 90 millimeters, give or take. Looks like it's about 90, a little bit short, probably closer to 85. Come straight down here like so, maybe like 18 millimeters down, or maybe it's actually a little less, 13 millimeters down here. So I'm just using the on-screen feedback here, making sure that these entities are approximately the correct length, making sure that I'm getting my horizontal and vertical relationships here as I'm sketching this geometry. And now this one's going to come over here, kind of coming up at an angle. This one's going to come straight up again, going to come over here horizontal. So I'm looking for that feedback, letting me know that I am in fact horizontal and exactly on that plane. And then I'll close off this sketch like so. Now I'm going to press D, which jumps me into the dimension commands. And what I do with my dimensions is I start out with kind of the smaller dimensions first. So for example, I'll take these dimensions here and I'll type them in at 5. Okay, and it looks like this one here I missed, so let me hit escape and double click on that one. 5, enter, and then I'll press D again. And then I go and add in my larger dimension. So for example, the dimension from here to here is supposed to be 90. And the reason I started with that smaller dimension is to avoid the sketch kind of like flipping over on itself. So now I'll create a dimension here that goes to this angle, which is going to be that lower angle, but it is still 10 degrees. It's the larger angle. This back wall here, which is going to come out at 36. And you can see here that the sketch is still under constrained, and FreeCAD tells me we've still got 2 points that are under constrained, 2 degrees of freedom still. So the final dimensions, if I'm looking over here at the print, it looks like I need to add a dimension that represents the distance from my kind of main datum down to this line here. Looks like that distance is going to be 13. And then the final one is going to be the distance to the, let's see here, I've got the distance to the top here, the distance to this shelf, the distance to back here where this angled shelf kind of hits that back wall. And it looks like that distance is going to be 20 millimeters. And so now you see FreeCAD tells us that that sketch is fully constrained, and that is what we want before we move on. So now I'm going to press Shift S to exit that sketch, X to extrude that sketch. I'm going to type in the total depth, 130, tab to get to symmetric to plane. I'm going to press the space bar to check that box on, and then enter to finish that first feature. Now I'm going to pick this face here, Shift S to begin my sketch. And now in FreeCAD, what I believe you need to do to reference these edges, and I could be wrong because I'm still kind of a noob, but what I believe you need to do is click on this icon here. Create external geometry. So I click on that icon first, and then I come down and I pick on this edge, and I pick on this edge, and then I can jump into the polyline command, and I can now reference those endpoints, and I can reference that geometry in FreeCAD. I know there are some FreeCAD wizards out there in the chat. When I shook the screen and I minimized everything, I did minimize the chat by accident, so I'm not actually reading it. Plus, I'm kind of trying to speed run this, so I'm going to hit escape here, hit escape a second time, but not a third time, because I don't want to kick myself out of sketch. I'm going to click on this point here, click on this point here, and I'm going to press C for coincident, and then I'm going to press D to jump into dimension. And now this dimension is going to come from the main datum to this point here on that kind of sidewall, and that dimension is going to be 10 millimeters. The sketch is fully constrained, so Shift S to exit that sketch, X to extrude that sketch. I'm going to reverse the direction of that extrusion and then give it the wall thickness here, 5 millimeters. 5, enter, and boom, we're done with that feature. Now I'm going to jump into a mirror command. So here's the mirror command in FreeCAD. So mirror, and this is going to be a mirror of a tool shape or of a feature. I'll click add feature here, and then I'll just click on this wall that I just created. And then the plane that I'm going to mirror about is going to be the same plane I started sketching on, the XZ plane. And that looks pretty good. All right, now we've got our mirror. Now I'm going to create a new datum plane. So I'm going to click on this face here, and then I'm going to click on this icon to create a new datum plane. And that datum plane is going to be offset. And one of the things that I found a little bit tricky about this workflow is if you're offsetting it normal to the face, you always pick Z. At first, what I was trying to do was offset it relative to the global XYZ, but that's not correct. It's kind of the local XYZ. So when you're trying to offset a datum plane relative to this face here, it's going to be offset in Z, and that offset is going to be I'll make this 12.5, so that first kind of space there, and there we go. That looks good. Click on that datum plane and Shift S to begin a sketch. And now here, I'm going to go up to the top of the screen here and change the draw style to wireframe. And now I'm going to kind of repeat what I did earlier where I use this icon to reference this edge and this edge. It's almost like a convert entities. It kind of traces those edges. Then I go to polygon, and once again, I'm going to create a line here that covers that first line. I'm going to create a line. Whoops. Messed that one up. Let me just Control Z to undo that. I'll just do it again. I think that'll be a little easier. Polyline again here from here to here. Polyline that comes up to about a little bit more than halfway. Don't pick up halfway. You don't want to get midpoint by accident. Polyline that kind of comes out here a little bit above, and then make sure you get vertical there. Hit escape, and then you can hit escape again. Pick this point, and it's going to be C for coincident, D for dimension, and this time the dimension is going to be from our main datum to this angled line here, and that dimension is going to be at 5 degrees, and the dimension is going to be from this point down to our main datum, and that dimension is going to be 23 millimeters. And once again, our sketch is fully constrained. That's what we want. So Shift S to exit that sketch, and then X to extrude that geometry, and that's going to come out to a depth of 5 millimeters. And now I'm ready to jump into my linear pattern command here in FreeCAD. So linear pattern, and again, this is going to be a tool shape. I'll say add feature. I'll pick a face off of that shape that I just created. And then for the overall direction, now this one will be global, so I'll go about Y here. Let's reverse the direction on that, and we're going to say the offset or the individual spacing is going to be it's going to be 25. I can't remember if it's 25 and then plus the 5. I think it's plus the 5. So that's going to be 4 instances, and yeah, it's going to be 25 plus the 5, so it's going to be 30. So that spacing between those looks pretty good. I'm going to hit OK. I'm just going to do a quick kind of like a sanity check here. So if I click on this edge here, and then I look down on the status bar, the length of that edge is 12.5, which is what's called out in the drawing. And then if I click on this edge here, and I look down on the status bar, I see the same thing. So I think we are good there. And so now I'm going to maybe go back to my tree and just hide my planes to make it a little easier to do my next selections for my fillets. I'm going to click fillet here, and this fillet is going to be, click here on fillet, and when I click the fillet here, yep, this one is going to be on the, let's see here, it's going to be on, okay, let's go here. I think I might have just done something a little bit weird. Okay, it's going to be on this edge, this edge, this edge, and this edge. At a little bit, not a FreeCAD expert, so when things go a little off the rails, I get a little nervous. Okay, that looks good. Those are at 8. I'm going to do a fillet here at 4, and that's going to be on this edge. Oops, let's do select here. This edge, this edge, this edge, this edge, and this edge. And that's going to be 4 and OK. And then finally, we're going to do a fillet of 2 on this back edge here. So fillet again, this one's going to be at 2, and it's going to be on this edge back here. And OK. And there we go. That is your soap dish. So now the only thing that's really left to do is to assign the material and then calculate the mass of this part. The thing is, this material needs to be very precise here, 20 kilograms per cubic meter. And I'm not sure if I have that in my FreeCAD library. So I'm going to go here to my body, and I'm going to say material. And I'm just going to go down through this list and get the generic ABS. So there's the generic ABS. But if I go into the materials editor, then what I'm going to learn is that that's not exactly 1020. It's actually 1060 kilograms per cubic meter. So let me just assign that, and then with that body selected, I'm going to bring up my macros, and I'm going to bring up my center of mass macro. And when this comes up, you can see here that the density of this part is 1060 kilograms per cubic meter. So the mass is 201.6 or 202 grams. So let's go back into the TooTallToby app and see if that's right. So we go into the app here, 202, and enter, and no, incorrect. That is not correct. So let's go back into FreeCAD into that macro, and we see here we can actually modify this density here. So if I modify that density and maybe bring it back to 1020, now we're coming up with a mass of 193.9 grams or 194 grams. So let's see if that works a little bit better, 194 grams. So 194 and enter, and oh yeah, we did it. That's what I'm talking about. And that is your FreeCAD LiveSolve. 10 minutes to model up that soap dish. Now I can take that model, I can export it to STL, I can bring it into my slicer and turn it into an actual 3D print, take it up to the kitchen and see if it works. You'll notice that there was a note here on the drawing. It's a note, let me go into try again here. It says note, this model is designed to hold a sponge which measures 120 millimeters by 80 millimeters. If your kitchen uses a different size sponge, consider modifying your 3D printed part. And that's the cool thing about doing these challenges on the TooTallToby site. You've got the model. So when you're done creating this model, whether it's in FreeCAD or Fusion or any 3D CAD system, you can then make changes to it, and then you can kind of come up with your own version of that 3D print. But now we can see that there's been a total of 13 people who have successfully solved this. The average solve time is 8 minutes and 18 seconds. And guys, the winner of this first point is MCGA, Sebastian. And he is also the person who created that app, that CADOp.io. So, CADOp.io is designed to help you save time and documentation. You can tell that MCGA is all about saving time. MCGA is all about helping you streamline your workflows. And that's what he's done here. He was able to solve that thing in just 4 minutes and 11 seconds. So the model was released at 1:12 p.m. He finished it up there by Looks like 1:16 p.m. Wow, that is super impressive. So congratulations to MCGA earning the first point of the day, followed very closely there by Rambro's Workshop, 4 minutes and 25 seconds. Gray, 4 minutes and 43 seconds. And Aaron C, 4 minutes and 51 seconds, all in sub 5 minutes from the time it was released. Super, super impressive. Good job, everybody, and congratulations. So we're going to get the next challenge ready for everybody, but let me just bring up the chat, and we'll see if there's anything going on in the chat that I missed that is important. And guys, congratulations. Huge congratulations to MCGA. That is awesome. Did anybody post their speed runs yet? I know sometimes people record themselves modeling it and then instantly post that in the speed run. So no, not yet, but I'm sure that that's going to happen. And now look, 15 people have already solved it. That is awesome. Lawrence says, haha, bringing up the rear. Yo, nice job, Lawrence. That's what's up. So let's see here. Let's see what we got. There we go. Very nice. Very nice. I like it. I like it. So cool seeing all these users in here. And that's Het Patal. He says, I got stuck somewhere in Onshape. Yeah, it can happen. It can happen for sure. All right, guys. Nice job. Nice job. Jim Yu. Solidarity here with FreeCAD. Let's go. Let's go. So that is actually, guys, that's my first FreeCAD live solve. I hope to do some more of those, but I hope you guys enjoyed that one, seeing kind of a newbie there working through FreeCAD a little bit more. It's a little bit more difficult. Should you do the rounding of the front edge before patterning? Dan, that's a great suggestion. Dan in the chat here says, should you maybe have done the rounding of that front edge before patterning? I think that's a fantastic suggestion. And yes, I probably should have done that. That would have made a lot more sense. And it would have helped me get to a solution a little bit more efficiently, because I wouldn't have had to go through and pick all those individual edges. So yeah, that's a great suggestion. All right, guys, I'm going to get the next one ready. You guys can kind of just shake it off here a little bit, talk amongst yourselves just for a moment, and then we'll get this next one going here. But this is, like I said, a very special episode. If you don't have an account yet at TooTallToby.com, make sure that you sign up for an account. This could be your chance to sign up for an account. Don't forget to hit the like button. Don't forget to subscribe. And like I said, you need to sign up for an account if you want to earn the points today. So visit us at TooTallToby.com. I don't know if I need to go all the way back here to tell you that, but visit us at TooTallToby.com, and that way you can sign up for an account and make sure that you've got the correct materials. I'll bring this up again as well, but of course you can take a screen capture of this if you want to make sure that you have the correct materials. We use these 4 materials throughout the app. The TooTallToby Practice Models app that you know, maybe you just tried it for the first time. That app has a library of over 200 of these challenges, going 2D to 3D, categorized by difficulty, set up with different types of models that you can create, like 3D printable parts or multi-body parts, assemblies, things like that. And so what you're able to do once you sign up for an account is you're able to access some of the challenges, but all of the challenges use these materials. So be sure to check out that app if you haven't been in there before. And if you like it, and if you're learning a lot from the app, consider signing up for premium. It's a fantastic value. You know, it's basically $6 a month if you sign up for the year, $5.80 a month if you sign up for the year. And that is a fantastic way to learn about 3D CAD and get access to some cool models that, you know, you could manufacture or do woodworking or even 3D print. So very cool app here, if I do say so myself. And let me just go through and just add a couple of final elements here, and then we're going to be ready for the next one. This is normally all pre-cooked because I only do this on one normally, but this time we are working with multiple challenges, 3 challenges here in one single live stream. So we're mixing things up a little bit here. All right, guys, here we go. This next challenge is going to go live in just a moment. And just want to say again, thank you so much for all the support to everybody in the TooTallToby community. And that was our first challenge. And we'll talk a little bit about news if time permits, but I don't know if it's going to. And so don't forget, please sign up for Practice Models Premium. That's what it's all about. Check out cadop.io, sponsoring our featured models this week. And you notice this week we're getting some bonus models. So huge shout out to cadop.io. Thank you very much to all our members. And this next challenge is live. So challenge number 2 is live. You can visit us at TooTallToby.com. You can click into the app, and you're going to see here that in the Practice Models library, there's now an additional featured model up at the top of the page here, 250908. Good luck to everyone. And this is a very special challenge because this one recognizes someone who signed up for our YouTube channel And this is somebody who's been a supporter for a long time on our YouTube channel. And huge shout out here to PCRDuino. Sorry the chat was up there for a little while, guys. But huge shout out to PCRDuino. He's been a member of our YouTube channel for quite some time. He signed up last year when we first started doing this promotion, and we finally got him added to the library. Thank you, PCRDuino, for being a member of our YouTube channel. You can see that this model is created in 1060 aluminum. It's made in millimeters, mmgs. And the question is, what is the mass of this part in x.x grams? So for this next challenge, and again, thank you, PCRDuino. Thank you for signing up for the YouTube channel, being a member at the Buy Me a Cup of Coffee level. We did run a promotion last year where members who signed up were recognized, had their own custom practice model created, and now that practice model has been added to the library, and you will forever be a member of the library. You'll go down in infamy. So congratulations to PCRDuino. FPV says, I remember this one. Yeah, this one has a little bit of a tricky feature to it for sure. And so what we're going to do now is we're going to do another live solve here on this model, and we're going to live solve this one using Onshape. So we're going to mix it up a little bit here using Onshape. Now, when we are doing this, so welcome everybody. Welcome to this live solve, this special episode of Model Monday Live, where we are doing 3 different live solves in 3 different CAD systems. And for this one, we're going to use Onshape. And whenever you're trying to model a 3D part, one of the first things you want to ask yourself is, where should the origin be located on this part? And I think that for a part like this, I'm going to be looking for kind of a common area where a lot of dimensions are coming from. And I think that on this part here, that common area is going to come from this dimension, this dimension, some of the angle dimensions, some of the other distance dimensions, like this dimension down here. They're all coming from the center of this circle here, the center of this circle here. So I think that's where my origin is going to be on this part. Now, this is one of these parts that you really could model this thing up using all one sketch. You could really kind of lay out the whole thing just using the sketch here, looking down from the top. And I think that's what I'm going to do. But what makes this part really interesting is this fillet. There's kind of a tricky fillet in this part. This fillet right here, this radius 13 that's right here, it's given me a hard time both in SolidWorks and Onshape. And so I'm going to model it up today, and I'll show you guys what I mean. But when we get to that radius 13, it really gives us a hard time. The thing is, you can't go to a customer and say to a customer, like, I modeled up your whole part except for this area here. I just had to leave this sharp because this fillet gave me a hard time. You know, you have to figure out a way to get around these types of challenges in CAD because the customer doesn't care. You know, they want the part to look the way they spec'd it out for you. And so it's up to you to figure out how to get it into that state. And sometimes those workarounds are pretty easy. They're just kind of brute force. But I really like this challenge because this challenge really lets you kind of examine that scenario that you will run into in the real world. So we're going to get into it here in just a moment. I did see a chat come in from Dan. He said, are people just submitting the stuff they make at work? Now, usually what I do, Dan, is when people join the channel, I do a little bit of a deep dive. Sometimes I know the people. Sometimes I do a little bit of internet research. And I noticed that PCRDuino had a robot that he's built with his team, with his class, and that it had an arm like this on the robot. And so I thought it would just make for a fun model. But yeah, that is funny. That would actually be kind of a cool perk if you join the channel. You can send me your homework and I'll just do it for you and turn it into a model. What's up, Victor K? Welcome. It's a very special episode today. We are doing 3 different live solves using 3 different CAD systems. So let's get into it here. This live solve is going to be using Onshape. Good luck to me doing this live solve using Onshape. And here we go. We're going to start out by going to the TooTallToby website. We want to give a huge shout out to CADOp.io, who's sponsoring this week's featured challenges. And the first featured challenge we modeled up using FreeCAD. And now we're going to model this one up using Onshape. So 25-09-08, we're going to say click here to practice. And go. And so we see here the challenge is and go. And so we see here the challenge is, actually, I'm a little thrown off here because I have the wrong CAD system in my profile. Let me just change my user profile real quick here. I want this to show Onshape because whenever you're using the app, the TooTallToby app, we do track your metrics and your analytics. And so it's pretty helpful when you can change your different CAD system. And then when you're done, you can look at the results and you can say, oh, I modeled this part this fast in FreeCAD, but then I modeled it this fast in Onshape. So here we go. We're at TooTallToby.com. We're up at the top here where we've got some featured challenge models. Of course, if you sign up for TooTallToby's Practice Models Premium, you can access a library of over 200 of these 2D to 3D CAD challenges, all filtered by different tags. You could do all sheet metal challenges or all, tier 1, tier 2, tier 3, the different difficulty. Sign up today, get started for free, and then if you really like the app, you can unlock the entire library. So we're going to do this one here, 250908, up in the featured challenges. Click here to begin, and go! And so the question here is, what is the mass of this part in xx.x grams? And as I mentioned just a few moments ago, anytime I'm trying to come up with a 3D model, the first thing I ask myself is, are there a lot of dimensions that are coming together at one spot? Because that would be a good location for the origin. In this model, there are. All these dimensions are coming together right here. I'm also going to be solving this using Onshape, and Onshape is a fantastic tool for kind of laying out everything in one sketch and then doing multiple extrusions coming off of that sketch. So I think my first sketch is basically just going to look like this entire drawing view here. So let's use this open in new window function, and we'll move this over here, this window over here to my other screen, and then let's bring up Onshape and see if we can solve this thing. So here we go. We're going to go into Onshape here. I'm going to solve this using my free seat of Onshape, and I'm going to put this into the public space. So that way, if anybody out there gets stuck trying to model this one up, you can just search the Onshape public space for my document, and then you can actually examine the history tree that I'm creating right now and maybe use that to help get unstuck. So let me just move this chat over a little bit here. And here we go. Get into Onshape, create document 25-09-08 PCRDuino. That way you can search for that text in the public space. The default units that I work in are millimeters, so I'm pretty confident that I'm already set up in millimeters. So I'm just going to jump right into the top plane, begin a sketch, N key to get normal to. I'm using the S key to bring up this menu here, and I'm going to create a circle. This circle is going to have a diameter of 60. And you'll also notice that that circle is extruded here off of the bottom of the part. So even though it's only a partial circle here in this view, like there's no need for me to kind of sketch and trim this up like so. It's a full circle over here on the bottom of the part. So I'm going to sketch that full circle there. Then I'm going to create another sketch here of a circle. I'm already in the circle command actually. So here we go, S key circle. I escaped out of it. And we'll make this circle here a diameter of 13. It's 13 through. And then we could hit escape, click on this edge here. We could use the offset entities command, and then we could offset that to a distance of 4. It's got a 4 millimeter sleeve there. Now we're ready to start getting in there and adding in some of those other lines. And one of the first things you could do here would be maybe to add this rectangle with a dimension of 6 wide by 22 high. And then you could jump into your dimension command. So I'm just using the S key to access that little menu, but you could use your dimension command to kind of locate this rectangle. And that might give you a nice anchor point to create some of the lines that you're going to be creating as you kind of run over and down through the rest of this sketch. So that's something that I often will do. I'll just draw in a couple of elements, and then I'll kind of lock them in, and then I'll move on with the rest of the sketch rather than trying to sketch the whole shape all at once. It depends on how complicated the sketch is, but certainly for more complicated geometry like what we're looking at in this sketch, this is a strategy that I use often. I'll just kind of draw a couple of lines. I'll add in some dimensions to those lines. So this one's at 35 degrees relative to that top edge. It's at 5 degrees relative to the other edge. So let me hit escape and drag that down a little, and then S key dimension. Make sure the 5 is going, the correct direction. So 5 degrees there. And then this is 10 millimeters for that wall thickness. And then this is out to that side wall from the center plane there looks like 33 millimeters. So if you go through and you use this technique when you're working with complicated sketches that have a lot of entities, it's kind of like a divide and conquer or like a bite-size approach where you're just trying to get a little bit at a time, little by little, kind of work through that model. So now we've got a line here that comes off of this one and goes right to our center plane and then comes straight down and then goes back, and it looks like there's a 10 millimeter wide dimension on that. So if I put my mouse over this line, I can kind of wake up that line and make sure that those two are parallel. So bring that line over like so, bring it down like so. And then this one, actually, the math works out that this one is also parallel to those lines, but the dimensions are called out in the print. So maybe I'll just make it kind of independent. So click here. This line is going to be perpendicular. You can see that 90-degree dimension. This one's going to be parallel to this line here, so kind of wake up that line and then get that parallel to show up. And then I can hit escape and then just take this point and press I to make those two coincident. See there, my sketch got a little tangled up. That can be a little confusing, especially if you're newer to 3D CAD or newer to Onshape. So I could take this line here and kind of drag it off to get that untangled. Now I'm going to go to my smart dimension, or to my dimension command. I'm going to type in 10 millimeters. I'm going to create a dimension here from this plane to this line. That dimension is going to be at 25 degrees. And then it looks like this line has a relationship to the center point of the circle. So you see we've got this little green line here going right to the center. So that's indicating that this, from the center point coming out, you get right onto this angle dimension here. And that's how you can kind of lock down that final angle. So we could hit escape here, take this center point, take this line, press I, and oh yeah, that line goes black. That's what we want. And then we can create a dimension here from the center to either this line or this point. Either way, sometimes I'll pick the line just to kind of lock down the angle. That one's going to be at 33. And then we got our sketch tangled up again here, hit escape, untangle the sketch. Okay, this happens when you get into complicated sketching, and it's just something that you kind of learn how to deal with. We'll make that 10 millimeters, and then it looks like we just got the one final dimension here from this plane to this. That's going to be at 65. Oh, and the height to that one's going to be at 33. Did I lock down the width of that one? No, got to lock down the width still too. And 10. So you can see that as we're going through that sketch, all those entities are changing from blue to black. And that's really what we want. We want to make sure that those sketches are changing from blue to black, meaning that sketch is becoming fully constrained. So now we can take that geometry and we can S key extrude. And when we go to extrude that geometry, we're going to hit the space bar on our keyboard because the space bar clears everything. And then we're able just to go through and kind of pick and choose which contours or which geometry we actually want to extrude. So I'm going to go through and pick this geometry here. All those entities are going to get selected for this extrusion. And then I'm going to reverse the direction and I'm going to extrude that down to a height of 4 millimeters. So that's that kind of lower region. Now I can show that sketch. And then with that sketch shown, I can maybe click a region from that sketch, and then I can jump into the extrude command again. So extrude, and now this geometry here is going to be that region. It's going to be this region here. It's going to be this region down here. Just kind of go and pick all that geometry, and now that's going to come up to a height of 10 millimeters. And then I could pick this region here, and I can choose to extrude that region. And that geometry is going to get extruded to a height of 16 millimeters, but that one's going to start at an offset. So you can see here that it doesn't start flush to this face here. It actually starts at an offset of 4 millimeters. And so we can reverse the direction of that offset. And yes, that looks good. That's what we wanted there from that one. So that's offset at 4 millimeters. There we go. And now all that's left to do is just to add in those fillets. So we jump into the fillet command here. So S key fillet, and the fillet here is going to have a radius of 13 millimeters. And we pick this edge here to fill it at 13, and then we pick this edge here to fill it at 13, and we pick this edge down here to fill it at 13, and then we pick this edge here to fill it at 13. And when we pick that last one, all of a sudden the preview goes away, and in Onshape, it even gives you a warning in the tree here. It shows up in red here in the tree, letting you know that that fillet is a problem. It's not working for some reason. Hit the green check mark. It doesn't work for some reason. So if I double click here on the fillet feature and I unselect that one single edge there, now all of a sudden the preview does show up. So for some reason that fillet, it doesn't want to complete. I think it's because we're eliminating this gap here and kind of changing this edge ID. And this happened not only in Onshape, but it's happened to me in other CAD systems when I've tested this model. And so you have to come up with a workaround, right? We have to come up with some kind of a solution. Well, the easiest solution, the most brute force solution, would be to just pick this face here, begin a new sketch, take this edge and this edge and convert them, turn them into the current sketch, and then launch the fillet command. So we go fillet here, and we're going to add a fillet here onto this corner, and that fillet is going to be 13. And boom, That gives us the geometry we need. Now, you know, if some CAD systems will let you pick that region, other CAD systems you have to trace here onto this region. Regardless, it doesn't take that many extra clicks. We go extrude, and then we could say we want that extrude to go up to face, and we want it to go up to this face here, and boom, you're back in business. You can get that part over to the customer. So you just want to be aware of that. Those types of scenarios, they do come up sometimes in CAD, and sometimes you have to just patch that region, whether that's like a brute force patch, doing some type of a blend, a loft. As you get deeper and deeper into CAD, you'll learn more workarounds for these types of scenarios, but they do happen occasionally. Okay, and then for my final extrusion, I just need to get this little sleeve area extruded up here. This little sleeve area here extruded up. So it looks like that sleeve area goes up to a height of 14 total, or 4 here above the original 10 from the, am I looking at that right? No, wait, that's not right. Hold on a second. 4 below, 4 above. Just 4 above. Okay, that's it. Just 4 above. Sorry, I was looking at that wrong. Not 14, just 4. So we'll take this region here. You can just click on it. Click inside of this region. Whoops, is it down below? Is that why I can't get it? There we go. Click on that region there. S key, extrude, and tab, tab, tab. 4, enter, enter. Boom. Done with that one. And then we're going to assign the correct material. So this is 1060 aluminum. So for this one, I do have the custom TooTallToby materials. Assign material. This one comes from the custom TooTallToby library. And this material is going to be 1060 aluminum. We hit the green check mark, go down here to measure the mass, click on that part, and we're coming up with 94.3 grams. So let's go back into the TooTallToby app and see if we got it. 94.3 and enter. And oh yeah, we did it. Congratulations. This is correct. Let's go, let's go, let's go. That's how we do it. So that is your LiveSolve there using Onshape. And wow, not bad, guys. We got 12 people who solved that while I was solving it. That is 13 people. That is awesome. So 10 minutes and 1 second is the average solve time. And let's take a look at our first 42 and find out who earned the point for this one. So for this one, it looks like the point is going to go to Gray. Wow. 5 minutes, 21 seconds, and MCGA right behind him, 5 minutes and 38 seconds. And Rambro's Workshop, 5 minutes and 58 seconds. Wow. So congratulations. And look at Aaron C here, 8 minutes and 19 seconds. Let's go, let's go, let's go. So even though that model looks like it's a pretty simple model, you'll see that even our world champion speed modelers, did take some time with it. It's not exactly the easiest model in the world. And even though maybe it only has one sketch, there's definitely some hiccups to that model. And that's why I really like that one. So thank you, PCRDuino, for having such a cool model for us to work on. That was a lot of fun to work through that one. And guys, congratulations to Gray earning that second point. That's what it's all about. And we're going to go in and take a look at our final challenge of the day here. Like I said, today is a little bit of a unique episode of Model Monday Live. It's kind of a speed run, almost a speed run in a way. For me, we're doing 3 challenges here in one episode. Usually we just do one. Usually we do 2 challenges, and we also do one single live solve. So it's kind of unique here that we're doing 3 challenges, but we wanted to make up for last week because we had only 2 points up for grabs last week. So we're kind of going through and making up for that a little bit in that we are, we're doing 3 challenges, 3 points here this week. So let me just double check, make sure I've got the correct answer in here. This does look good. And I'm going to let this last one rip here. So this last one should show up in the app here momentarily. And guys, don't forget to hit the like button. Don't forget to subscribe. I hope you guys have been enjoying this. Hit the like button, subscribe to the channel, and it's a lot of fun. It's a lot of fun to go through these challenges. Matab says, I don't know why, but I'm way slow in the website. Oh, it's all good, my friend. It is all good. Rockcrawler says, GG to all you speed demons. Yeah, a lot of really impressive results there from everybody. Really cool to see that kind of top 42. But this next one is now live, and we are running a little bit behind on the schedule. So get in there, give this next one a shot, access full library. We want to say thank you so much to CADOp.io for sponsoring this week's featured challenges. If you want to learn more about CADOp.io, you can click on the link here, and you can learn about how they can help you with documentation from a mobile device. Pretty cool to get all the stakeholders together via that mobile app. But here you can see the final challenge of the day, 250909. And guys, this is a fun one. This one is thanks to our good friend, Yup, That's Me. Thank you to Yup, That's Me for being a member on our YouTube channel at the Buy Me a Cup of Coffee level. He's been a longtime supporter of the channel, and we can see here that this one is a rocket launching station for model rockets, and you can see that this is actually a multi-body part. So not all of our challenges are just single parts. Some of our challenges are assemblies, and this one here is one of those where it's kind of like a multi-body part assembly. So we're going to get into our final live solve here of the day. And in this final live solve of the day, we're going to be using SolidWorks. So 3 different live solves, 3 different CAD systems, kind of a special episode here. It's going, I think it's going a little bit too fast. I think I'd be more comfortable maybe doing 2 live solves, 2 CAD systems. 3 is maybe a little bit much, but 3 different live solves using 3 different CAD systems. I hope you guys are enjoying seeing these live solves, seeing these 3 different CAD systems in this one single live stream. Where else can you go to see 3 different CAD systems in one single live stream? The answer is, of course, nowhere. There's nowhere else you can go. Like and subscribe. And guys, for this final challenge here, we are going to be taking a look at SolidWorks as our software to do the live solve. And don't forget, guys, please join the party. Consider joining the party. Don't forget, if you guys enjoy the Practice Models app, which you're getting a little sample of here during today's live stream, consider signing up for Practice Models Premium. It's only about $6 a month if you purchase it for a year, and it gives you access to a library of over 220 2D to 3D CAD challenges, and these CAD challenges are organized by challenge level, so you could start at the easiest ones and kind of work your way up, or organized by challenge type. You could say, I want to do all sheet metal challenges, or I want to really focus on 3D printable challenges and print these things out. Which, by the way, I know there's a lot of people in here who have done some of these challenges. Just in case you guys were ever wondering, I know this looks like a coffee mug. This is actually the cap for a trampoline. So if you have a trampoline in your backyard, or if you know somebody, if you have cousins or nephews or nieces who have a trampoline in the backyard, when the net starts to fall down, a lot of times it's because these caps break. They're usually made out of like a really thin plastic material that's out in the sun. So if you 3D print this out of like a PETG or a TPU, especially a TPU would be great. If you could print it out of like a rubbery, like a TPU, it's fantastic because it'll actually stretch as the trampoline pulls on it. But just in case you guys are ever wondering about this one, that's what it is. Post cap. It's a cap for a post on a trampoline. That was just like a little bit of a side note. I figure we have so much extra time in this live stream, I'm just going to go down some different tangents here as we're talking about the Practice Models app. But guys, I hope that you guys enjoy this next challenge, 250909. We're going to get into it here in just a moment. FPV Kev says he struggled with that cap one. Yeah, that one is rough. 94.3 grams was correct for PCRDuino. And guys, we're going to get into our 3rd challenge. And in this 3rd challenge, we are going to be doing a live solve using SolidWorks. What's up, Edwin? Thanks for joining us here today. Guys, sorry there hasn't been as much interaction with the chat today. We've been running a little bit slow. If you have to leave, I totally understand. And don't forget to hit the like button before you leave. And don't forget that this Friday, we are going to be live streaming the tournament. So don't forget this Friday, we're going to be live streaming the tournament, September 17th. Matches 5 and 6. Be sure to tune in for that. And, of course, join us next week for a regular episode of Model Money Live. It's going to feel like we're going in slow-mo next week compared to this speed running marathon here today. But let's give this guy a try. So CAD challenge number 3 of today's live stream, you can go to TooTallToby.com. When you go to TooTallToby.com, you can log in. You can see that you can access the full library. And these featured models are going to stay up for a few days, probably not the whole week, but we'll leave these up for a few days, give people a chance to try some of these featured models. And then you'll be able to access some models for free using the TooTallToby free account. And then if you want to access the entire library, you can sign up for Practice Models Premium. It's only about $6 a month. If you buy it for the year, and it's a great way for you to continue your CAD education. And so this one here is in our featured models, brought to us by CADOp.io. Modern CAD documentation simplified. You can get all your CAD documentation into the hands of all the stakeholders via a mobile app, which shows you things like bill of materials and costing estimates and technical specifications. Really cool app. Check that out. Let's get into our challenge here, 250909. So we're going to live solve this one using SolidWorks. Wow, and 3 people have already solved it. It's only been up for 4 minutes, and 3 people have already solved it. Oh my gosh. Here we go, guys. This next CAD challenge begins now. Go. What is the mass of this multi-body parter assembly in XXX grams? We're going to try to model this up and drop it in down here. Now, this is a multi-body or an assembly type challenge, so you can see that we've got the base, which is this part here with the 3 legs. And then we've got the rod over here. So this is for launching rockets. So this is the rod over here with a little blast deflector for the rockets to take off from. And so we can see that this is made out of plain carbon steel. This is made out of ABS. I think it makes the most sense just to model this thing in 2 parts, or at least in 2 different bodies. And then you can work with them together in a multi-body part or an assembly. So I think that I'm going to do this first part of the challenge by starting out with this kind of hex shape, looking down from the top, and then I'll create the leg and then remove the material from the inside of the leg and pattern it. And then I'll create the second shape here just using a simple revolve. So I could just sketch up a revolve there and create that rod with the blast plate kind of all in one shot. So that's my game plan for this model. It's always good to come up with a game plan. As far as where will the origin be located, I think I'm just going to locate it right here, right at the center of this hex and kind of on top of where this hex is. A lot of dimensions seem to be coming from there, and of course, it's the center of our pattern. So those are good reasons to pick that as your origin. So I'm going to open this up in a new window. That way I can move this window over to my second screen, make it a little bit easier to see all my dimensions. And we're going to get into SolidWorks and see how long it takes us to model this thing up. So here we are in SolidWorks for this live solve. And let's get into it here. I'm going to choose new. Now, one thing you can do to save time in SolidWorks is you can set up some templates. You can see I've got my template set up here in inches and millimeters for the different materials that we use in the TooTallToby library. And I've stored all those right here, TooTallToby 2024 templates. So it's easy to get to them anytime I've got a new challenge. So we're going to use this millimeters and steel. And then we can go in here to our top plane, sticking with our game plan, begin a sketch, S key. Looks like actually I don't have hex on here on my S key menu. So I'm going to go hex, and then I'm going to click over here, or polygon, click over here, click out here in the background, and then I'll just jump into my smart dimension command, S key smart dimension. The size of the hex there is going to be 48, and looks like this point and this point are going to be vertical. So pick one, hold control, pick the other, make vertical, S key, extrude. And then this is going to go out to a depth of 70, shown there on the front view. Right click, reverse direction, right click again. And now I'm going to go to this top surface here, and I'm going to create my extrude cut. So S key, begin a sketch, make a circle here, 10 millimeter diameter, S key, extrude, and that's going to go down to a depth of 40, enter, enter. Now I'm going to go to my front plane, begin a sketch, orient my view, and I'm going to take this edge here from the hex, convert it, and then I'm going to go to the line command and just kind of create these lines here, a line over, a line straight down, a line back up to this location. Now I can start adding in my dimensions. So dimension from the origin to this point, or to this outer edge here, is 220. The length of that outer edge there is 30 millimeters. The depth from the top of the part down to the bottom point there is 122, and boom, that sketch is nice and fully constrained. S key, extrude, and that's going to come up to a point here. So it's going to come up to this point here, and for direction 2, it's going to come up to this point here. And so now to sketch those pockets, what you're very tempted to do when you go to sketch those pockets is you're tempted to pick this face here and begin a new sketch. Pick this face, begin a new sketch, orient your view. The problem is that those pockets are defined as coming offset kind of from the middle of the part. 6 central wall here. So looking at the drawing and kind of thinking about the drawing a little bit and planning out before you get started might actually save you a little bit of frustration, a little bit of effort. I mean, of course, you could always do your extrusion offset from surface to get to that point, but it might be a little bit easier. It might be a little bit more elegant to actually create that sketch plane first. So in other words, maybe I could go to my front plane, hold control, put my mouse over the front plane so I get that little 4-way arrow. Oops, let me get my keyboard cam here. So pick on the front plane, hold control, put my mouse over that front plane, then left click and drag, let go of my mouse, let go of my control key, and then I could type that in as 6/2, enter, enter, and now that gives me the perfect location to start the sketch for that cut. So pick that plane, begin a sketch, orient my view, and we're going to take this edge, and this edge, and we're going to choose to offset those entities. Let's reverse the direction of that offset. We'll make that offset 6 millimeters, enter, enter. In SolidWorks, you can just grab these endpoints and drag them over. So that's kind of a cool thing you can do after you convert or offset. We'll convert this guy here, S key trim, and we'll trim this up like so. S key extrude, right click in the, S key cut extrude. Right click in the background, reverse direction, move your mouse a little bit, right click in the background through all, right click again. That finishes that command. Now we can pick our front plane, hold control, pick that feature, let go of control, mirror, because we did a right click and we customized this mirror. We actually did that last year. Mirror, so we can mirror that right over that front plane. So pick this one, hold control, pick the plane, let go of control, mirror, enter. Done with that mirror. Now we can take those two features and we can choose to create features circular pattern. And that circular pattern is going to be about this circular edge here. And it's going to be a number of instances 3 at 360, enter, enter. And oops, let's see here. It didn't like something about that. It might have been actually my cut extrude that it didn't like. Let's see if we do geo pattern, if that fixes it. Doesn't like that either. Circular pattern resulted in disjoint bodies. Oh, the cut extrude, the mirror. Oh, I forgot the boss. There we go. That's what the problem was. No? Now geo pattern shouldn't be on. Nope, still doesn't like it. Okay, yeah, it is. It might be that I could do it as body pattern. The other thing is, because the end condition of the cut extrude is dynamic, like when you do, basically what could be happening here is when you do a cut extrude through all, the end condition is dynamic, and sometimes it's a hard time solving that end condition, because what through all means is look at the boundary of the part. So the part has a bounding box. You can imagine this part has a bounding box here. Look at the boundary of that box and then extrude cut until you come to the furthest point on that bounding box. And that's where you're going to stop it. Well, sometimes when you do a pattern, that math gets mixed up. So sometimes you could resolve this just by adding a kind of like a dummy dimension to the end condition. So instead of this being through all, make it blind and just have it come out like 40 millimeters, something like that. And then if we go into the circular pattern and try this again, let's see if it works any better. So we've got our boss extrude, our cut extrude, our mirror, and the vertex defined for the up to vertex end condition is not. Oh, it's this one here. It's this guy that's the problem. It's the up to vertex going up to that point there. So that's where geometry pattern should solve for us. But it doesn't like that either, man. Yeah, so when this happens, again, you can't just go to the customer and say, sorry, Mr. Customer, I can't do it. What you could do is you could do a body pattern and just pattern the whole thing using a body pattern. So you could go circular pattern, say this is your direction 1, and then you could say this is the body you're going to pattern. You pick this entire body here. The hex is going to overlap with itself. The hole is going to overlap with itself. So it's not really a problem. You're just going to end up with kind of doubled geometry in the center area of those bodies where those bodies overlap. But then what you could do is you could do what's called a combine. So you could pick this first one, hold shift, pick this last one so all 3 of them are selected, right click, and you can choose combine. See, combine is a feature command, insert, features, combine. It's down here in the feature menu. But if you ever multi-select bodies from the body list in SolidWorks, if you pick this body here, and this body here, and this body here, and then you right-click, combine also shows up there, so it saves you having to go into the menus. So combine, add, merge those bodies together, boom, we're done, we're ready to move on. So that is how you can get around a pattern not working. If it doesn't work as a feature pattern, just do it as a body pattern, because that's like a true Boolean. Yeah, that vertex, that up to vertex was what ended up getting me. So now that we've got that pattern created, now that we're good with that guy, now we are ready to move on to our second element in this design. I got this extra circular pattern here that I don't need. Let's get rid of that. And then, of course, even though this is a speed run, it's still good to rename your features along the way. So this could be called something like hex base. This could be called hole in hex. This one here could be called leg 1. This one could be plane for web in leg. This one here could be called cut for web in leg. And then this one could be called mirror of cut for web. And then this one here, or actually I'll call it web in leg. And then this one here could be called circular pattern. I'll call this one body pattern for leg pattern. And then this one will be called combine bodies for legs. Now, the reason that I wanted just to point that out to you real quickly here is that when you use this filter up top here, if you rename your features, that filter will let you type in something like leg, and then you only see the features in the tree that have leg in their feature name. So if you get into the habit of renaming, don't just rename randomly. Like, make sure you put the same syntax in for different features, because that'll make it a lot easier for you to actually filter and take advantage of that renaming. I mean, the main reason we rename is so we can look at this thing later and we know exactly what feature is what, and we kind of like, it's almost like a instructions or like a recipe for how we built this part. So it makes it a lot easier to digest it when you're looking at it again 6 months later. But it's also beneficial if you want to start leveraging this filter up top here. So now let's go to our front plane. Front plane, begin a sketch, orient our view, and now we're going to create that other body. So for this other body, we're going to do a revolve. We're going to kind of start down here, come up like so, come over like so, come up like so, come over like so, come up like so, come over like so. We're going to come straight down here right where the origin is, and then we're going to close this thing off. And then we're going to create a center line, and the center line is going to help us when we go to do the revolve, because the center line is going to let us create what are called doubled dimensions. So what that looks like is when we go to Smart Dimension here, we click on this line, click on the center line, cross over the center line, and that's going to be a diameter of 10. So you notice I'm looking here now at the directional rod and the blast platform here. So the blast deflector here. So we've got the 10 millimeters down here. This is going to be 6. This is going to be 50. This one up here is going to be 5. And then the length of this one is going to be 670 minus 4. I don't want to say the number, but it's going to be, that's going to be the length of that one. So we're going to say here that this dimension here to that blast deflector, if we cross over that center line, is going to be 150. That was in that top view of that component. The diameter of the rod here is going to be 5. The distance here of this lower region is going to be 50. The wall thickness of the blast deflector is going to be 6, and then the length of this one here is that length that we talked about earlier. And then finally, what we're going to do is we're going to locate the height of this thing. So the height of this thing is going to be relative to the hole in this original part here. So if we just change our view style here to wireframe or hidden line shown, we can take this line here, hold control, pick this edge here of the bottom of the hole. So this line here, hold control, take this edge here, the bottom of the hole, let go of control, collinear, and now we see that sketch is fully defined or fully constrained. So nice fully defined sketch. It still says underdefined. Whoops, this line here is still blue for some reason. Maybe it didn't lock in on the origin. That's what happened there. So this guy, coincident. There we go. Nice and fully constrained, fully defined, fully constrained. That's what we want to see from all our sketches. And now we can finish off here by doing a revolve this shape here. So features, revolve. And when you go to do the revolve here, you're going to say, don't merge the results, because we want these to be 2 separate bodies. So if we say, don't merge the results, we hit the green check mark, and boom, now we've got those 2 separate bodies. Here you see you've got body 1, body 2, kind of like what we had earlier when we did that pattern. I'll click on this and I'll click the little eyeball, and there we go. There's our 2 bodies. Now, what you can do if you're doing multi-body design in SolidWorks, you can right click on one of these bodies and you can say material, and then you can change that to a material, whatever material you want. I'm going to make that lower part out of ABS per the bill of materials. And then you can go to this upper part here, right click, and you can say material, plain carbon steel, and boom, you're good to go. You got your 2 materials. But you can actually take this a step further if you go to the weldments tab. So here, if you go to tabs, weldments, so you see I'll turn the weldments tab off, so now it's not there. Right click, tabs, weldments. Now you'll notice that currently I've got solid bodies 2, this one and this one, 2 different solid bodies. Okay, underneath each of these you see the material for each part. And now what I'm going to do is I'm going to go on the weldments tab, and I'm just going to click this first button here that says weldments. So I click on that first button that says weldments, and once I click on that first button that says weldments, what happens is a weldment was added here, a feature called weldment was added here, and the solid bodies folder changed to a cut list folder. So what that means is now I can right click on that solid bodies folder and I can say update or update automatically, either one of those. I can say update or update automatically. And once I do that, update or update automatically, now I've got actual cut list folders here. And this cut list folder can be renamed. So I could rename that to something like base. And the cut list folder has its own properties. So I can right click on the cut list folder and go to properties, and I can input information like material, description, really anything I want I can input here for the base, and anything I want I can input here for the second item, which is currently called cut list item 2, but it could also be called, blast deflector, blast shield, something like that. So the thing that's cool is that even though this isn't like a structural assembly, you could make it a weldment, and that way you could easily input or insert a weldment cut list, which kind of looks like a bill of materials. So even though it's a single part file, that's how you make these bill of materials in your drawings in SolidWorks. If you have a single part file that's multi-body, go into your weldments tab, add this icon here. So there's the weldments tab. Add this icon here from the weldments tab. That adds a cut list here. Make sure you choose update or update automatically, and boom, you got yourself some cut list items that you can name. So there's the name showing up there. And you've got some properties that you can input here, like material, density, description, things like that. And then when you go into your drawing, you can do insert weldment cut list. Even though this is a plastic part and another part that kind of sits down inside of it and there's no welding going on, it's pretty cool that you can do that when you're trying to design in multi-body. Anyhow, I got a little off track there. We were already in overtime. I figured I'd give you guys some bonus here as we go into overtime. Let's go to our sensor here in the tree. I always use sensors instead of using evaluate mass properties. I just add a sensor here in the tree, and then that's part of my template. Whenever I start a new part, I look in the tree, and there's already a sensor there in the tree looking to calculate the mass. So you just make one and add it to your templates. You can search my YouTube channel. There's a video on how to add sensors in SolidWorks. So I'm going to do a Control Q just to rebuild everything. Looks like the mass that I'm coming up with here is 1453 grams. So let's go back into the TooTallToby app and see if we got it right. 1453 grams and enter. And oh yeah, this is correct. We did it. We got it correct. So congratulations. This answer is correct. Yes. And we'll say submit. And boom, we got ourselves another point on the community scoreboard. So we now got 30 points here on the community scoreboard. Not bad. And it looks like 15 people were able to solve that one. Let me refresh and just see if that updates. So yeah, it looks like 15 people were able to solve that, and the average time is 12 minutes and 2 seconds for that one. And guys, let's see who earns the point for this challenge. The winner of our coveted Model Monday Live leaderboard point is Rambro's Workshop. Yo, congratulations. 4 minutes and 34 seconds. That is screaming. And wow, look at MCGA right behind him, 4 minutes and 37 seconds. 3 seconds behind. That is amazing. So this model was released at 1:54, and these guys both finished it. Really, all three of these guys finished it here before the top of the hour. That is incredible. So congratulations. Congratulations to Rambro's Workshop for earning that third point of the day. Congratulations to MCGA for earning a point today. And congratulations to CSWE Victor just for being a heck of a nice guy, and also for being our 2023 world champion of 3D CAD speed modeling. Gray, congratulations as well. I believe Gray earned the third point today. Is that right? I can't remember who earned the third point. I'll have to go back and look. Guys, congratulations to everybody who finished that model in that limited time. Yo, look at the Onshape crew is here. Congratulations. Uncle Face, CAD King, Casca is here. Chris Odom is here. PCRDuino, what's up? What's up? And Chig OZI is here. And of course, Het Patel, CoolMech15. Congratulations. That is awesome. Well, guys, we went into a little overtime there. Lawrence says, thanks for a cool Model Monday Live, his first Model Monday Live. Thank you, my friend. Thanks for sticking around. We usually end pretty consistently at the top of the hour, but we decided to mix it up a little bit here. Oh, Lawrence is Uncle Face. Okay, awesome. That is awesome. So congratulations to everybody who earned the points today. Congratulations to Rambro's Workshop. Well done, my friend. Congratulations to, let me just check the other ones. Congratulations to... Let's see here. You guys who have been here for a while, you may have noticed that we added the return to the library link here at the top of the challenges. I wasn't there before. It's pretty nice. Congratulations to Sebastian. Yo, well done, my friend. And congratulations to, who got the third one? Gray. It was Gray, yeah. Congratulations to Gray as well. 3 real Speed Demon Wizards. 2 of them are still in the tournament, Sebastian and Gray. So, tune in on Friday. You can see how the tournament is going. Don't forget to like the channel. Don't forget to subscribe to the channel. Hit the like button on this video. Jim Yu coming in with some NOK. Thank you, my friend, for the super chat. Very much appreciated. And guys, I hope you enjoyed those 3 live solves. Our first time busting out FreeCAD during the Model Monday live streams. I hope you guys enjoyed that. Hope you enjoyed seeing Onshape, and I hope you enjoyed seeing SolidWorks. Congratulations to our winners for earning those points today. Thank you so much to Jim Yu for the super chat. Super chat is open to all of you out there in the chat. Thanks for sticking around on this episode. And don't forget, this Friday, September 17th, we see matches 5 and 6. And next week, we will be back for another slightly more traditional Model Monday Live. Rambro's Workshop says, I love the FreeCAD action. Thank you, my friend. Thank you, thank you, thank you. Thank you all so much, as always, for joining me on this episode of Model Monday Live. It's always such a fun way to start the week. It's so fun hanging out with you guys. It's so fun having this space where we can do our competitive CAD gamification, esports, whatever you want to call it. It's a lot of fun to get in here and do these challenges. So I hope you guys enjoy. Make sure you send the app, the TooTallToby practice model app, out to other people. Let them know that that's a great place that they can get in and do some CAD practice. Let them know it's a great place to learn. We've got tutorials in all of the Tier 1 challenges, and we're working our way through all the Tier 2 challenges as well. So it's a great way for people to learn more about 3D CAD as well. So send them over, and thank you guys so much. Thank you, Anthony. Thank you, Peekaboo. Thank you, Matab. Thank you, PCRDuino. Thank you, FPV Kev. Thank you, Rambro's Workshop. Thank you, Het Patal. Thank you all so much. Great to see you. Great to have everybody new in here. Great to see some new names in here. And great to see some old friends in here as well. Guys, I hope you have a great rest of your Monday. I hope you have a great rest of the week. I'll look forward to seeing you Friday in the tournament. Otherwise, I'll see you next week for the next episode of Model Monday Live. See you, everybody.